Warning: this experiment involves corrosive sulfuric acid, the production of toxic hydrogen chloride gas, and high reaction temperatures. Hydrochloric acid is an aqueous solution of hydrogen chloride. It is a very commonly used reagent in chemical experiments, but its maximum concentration is usually 37%. In this video, I will try to dissolve a large amount of hydrogen chloride gas at low temperature to explore whether the concentration of hydrogen chloride gas can exceed 37%. First, weigh 58.5 grams of sodium chloride. I found that some of sodium chloride was already caked, so I grounded it before doing this experiment. Add the sodium chloride to the flask, and then I added a few grams of boiling stones to prevent possible bumping during the experiment. Then weigh 15 grams of 98% concentrated sulfuric acid, and then weigh 15 grams of water into a collection container to dissolve hydrogen chloride gas. In order to increase the yield, I plan to use a magnetic stir to stir the collection container to increase the air-liquid contact area. The principle of this experiment is based on the metathesis reaction between sodium chloride and concentrated sulfuric acid. Since there is almost no water in the reaction container, the generated hydrogen chloride gas will be dissolved by water in the collection container. Calculating according to the chemical equation in theory, we will get 1 mole of hydrogen chloride, which is 36.5 grams, using 15 grams of water to absorb it. The theoretical maximum concentration is 42.2%. Whether such a huge amount of hydrogen chloride can be dissolved in the end remains to be explored experimentally. I am going to use a drop-in funnel to slowly add concentrated sulfuric acid. As for the collection container, in addition to using magnetic stirring, I also prepared a sink and used an ice water bath to lower the temperature to increase the absorption rate of hydrogen chloride. This thermic thermometer can more sensitively monitor the temperature of the ice water bath. When the temperature is found to become high, you can add more ice cubes in time. Add the sulfuric acid that has just been weighed into drop-in funnel. After preparing the distillation device, start circulating condensed water and start adding sulfuric acid dropwise. You cannot turn on the heating at this time, and wait until all the sulfuric acid is added dropwise before heating. Concentrated sulfuric acid and sodium chloride can only react in the first step at room temperature or a lower heating temperature. The products are sodium bisulfate and hydrogen chloride. The second step reaction can only proceed at high temperatures of 500 to 600 degrees Celsius, causing sodium bisulfate and sodium chloride to continue to react to form sodium sulfate and hydrogen chloride. We can see a large amount of white mist in the collection container, which is a phenomenon produced when hydrogen chloride encounters moisture. I tried opening the lid, and I could see a large amount of hydrogen chloride gas leaking out. So far, the experiment is going quite well. In the video on making hydrobromic acid, we used most of the same experimental principle, but the difference is that when making hydrobromic acid, we only used the first step of the reaction, which is the reaction of sulfuric acid and sodium bromide, to generate sodium bisulfate and hydrogen bromide. Because I am more worried that the high temperature required for the second step reaction will damage flask and heating mantle. But in today's experiment, I'm still prepared to let the second step reaction proceed to the end. This is to avoid wasting the hydrogen provided by sulfuric acid. After all the sulfuric acid has been added, remove the drop-in funnel and start heating at the highest level to promote the second step of the reaction. At the end of the experiment, I turned off the lights, and we could see that the experiment was still in progress, but I found that the heating mantle was already red hot, which indicated that it had been heated to an extremely high temperature. After turning on the light, there was only a pile of solids left in the flask, and no reaction phenomena could be seen. I guessed that the entire reaction was almost over. The remaining solids were sodium sulfate, so I stopped heating and prepared to end the experiment. When I took off the collection container, I obviously felt that it had become heavier, which indicated that it rarely dissolved a large amount of hydrogen chloride gas. We all know the concentrated hydrochloric acid revolatilizes hydrogen chloride, so you can see a lot of white mist when you open the bottle cap. Let's measure the concentration of the hydrochloric acid. I'm going to use the acid-base neutralization titration to measure the concentration. First, weigh 1.05 grams of the product, then dilute it with water, and then drop some with orange indicator. The standard solution uses a self-prepared 1 mol per liter sodium hydroxide solution. The color of the solution turns yellow. The amount of sodium hydroxide standard solution used was 12.25 milliliters. I wrote a simple CPP program to calculate the titration data. The calculation results showed that the concentration of hydrochloric acid was actually 42.58%, which even exceeded the theoretical maximum. So I suspect that the titration error is large this time, but I have another way to determine the concentration by measuring the density. The graduated cylinder is 31.08 grams, measuring 25 milliliters of product. The total weight is 16.74 grams. The mass of 25 milliliters hydrochloric acid is 29.66 grams. The density is 1.1864 gram per cc. By looking up the hydrochloric acid density concentration comprehension table, we can see that the hydrochloric acid concentration is 37%. Let's assume for the moment that its concentration is just 37%. After knowing the concentration, we then calculate the yield. The total weight of the hydrochloric acid obtained is 82.76 grams, and the mass of hydrogen chloride contained in it is 13.62 grams. Theoretically, 36.5 grams of hydrogen chloride should be produced, so the yield is 83.89%. I guess the reason why its concentration did not exceed 37% is that the temperature of the ice water bath did not reach very low. It was still close to room temperature, or the reaction was not complete, because I ended the experiment prematurely. Of course, a better way may be to reduce the initial water in the collection container, which should make the concentration exceed 37%. Thanks for watching.